Hello and welcome. This is going to be a short tutorial video where we re-go over the notes to section 6.1, Graphing a System of Equations. Recently we also learned how to solve a system of equations using the substitution method and the elimination method. So if you're feeling a little unsure about any of these three, watch these short videos where I re-go over the notes and talk about some common problems and situations that we might run into. So here we go. Let's take a look at our notes again for 6.1. First, what we need to know is we need to know what the definition of a system of equations is. And the definition is merely two or more equations that are grouped together. Now, when you group more than one equation together, your answer becomes more specific, that you must find out what x and y are simultaneously. And when we talk about our graph, that's going to be called the intersection point. So our goal is to put both lines down on one plane and figure out where they cross. Remember that a point is always x comma y. So when we do find that intersection point, let's be sure to label it. Now in the last chapter, we talked about how do you even graph one line. Well, the first thing you do is you start with the y-intercept, which is always going to be your extra number that doesn't have an x with it. So this is the y-intercept, or y-int for short. So I'm on my y-axis, this is the y-axis, this is the x-axis. I'm going to start down there at -4. The number in front is telling us what the slope of our equation is going to be. So if the slope is 2, we know that all whole numbers can be represented as that fraction, telling us that we are going to go up 2 and we are going to go to the right 1. By default, our run in the rise over run for slope is always going to be a 1, unless it's a fraction telling us exactly how far we're going to go over. So from this -4, I'm going to go up 2 over 1, up 2 over 1, and I'm going to do it many, many times because our goal is to find an intersection point. So the more points I have, the better. There we go. Now since I'm using my not normal tablet, it's going to be much harder for me to draw this line, so I'm going to ask you to bear with me. Okay, that could have been a lot worse, so I'm pretty proud of myself right there. That's our first line. Now I'll just use a second color for the second line. We're going to follow the same process again. I'm going to start with the y-intercept, so this time +6, and now my slope is actually negative. So that's telling me that I don't want to go up 3, I want to go down 3. So from our starting point, down 3 over 1, down 3 over 1, and you can see, not so good. You can see where we're going to find our intersection point. Okay. There we go. So again, this isn't my normal tablet, but the intersection point would be 2, 0. It's important to label the intersection point because it's just like telling the conclusion to your story. You just want to be as courteous as possible, and it also helps me be able to figure out if you're on the right track. So there are some things you have to keep in mind. One thing you have to keep in mind is not every system of equations is going to be nice to graph. For instance, here our first equation is in the lovely y equals mx plus b form, but our second equation is not in that form. So the hint that you'll have to take care of is sometimes you will have to change the form of the equation. And that's again something that we worked on last chapter. We learned how to turn any of these equations into y equals mx plus b. The first thing that we need to do is we would need to make sure the y is all alone on one side of the equal sign. So I will subtract 5x from both sides. But when you do that, they don't combine. So the 14 doesn't have any x's, so it stays separate. Right now we don't have a single y, we have two y's, and the 2 is being multiplied. To undo that multiply, we need to divide by 2. And this is where students often get caught up, is they forget to divide everything by 2. So they might remember, hey, I'll divide this by 2, but they won't remember divide that by 2. And after that, we have negative 5 over 2x plus 7. So now both of these equations are in a graphable form, so we're going to go ahead and graph those. The first one is going to start with that y-intercept of 1. So we're going to put our first point here. And the slope is telling me to go up 1 and to the right 2. This time they specified a different run. Up 1, right 2, up 1, right 2, up 1, right 2. So again, you would draw that line. There we go. And let's try the second equation, which we made down here. Our y-intercept is 7, so we start up here at the top. And now our slope is negative again. Now it's telling me to go down 5 and to the right 2. So down 1, 2, 3, 4, 5 over 2. And again, we get lucky. We can see where that intersection point's going to be. That intersection point is at an x of 2 and a y of 2 as well. So that's something that you got to watch out for right there. Not every equation is going to be ready to graph. So you're going to have to use your skills from last chapter to switch it around. Let's do a few more questions that you might run into here and there. Number 2, this is a question I get a lot, where students are looking to figure out what the slope of this first equation is going to be. If you have negative x, that's the same thing as saying this slope is negative 1x, which is telling me to go down 1 and also over 1. So if I were to graph that, my y-intercept is 3. We start up here, down 1 over 1, down 1 over 1, down 1 over 1, and we keep going through it. So there is our first line. Now, time to graph the second equation, which is starting at negative 4, and it's telling us to go up 6, 1, 2, 3, 4, 5, 6, over 1. And we can see where that hits. It hits right there at 1, 2. So again, remember, if your slopes are whole numbers, you can write those as fractions by using a little, divide by 1, sort of like a sneak attack. Another thing that you might find quite handy is, let's keep going. Okay, a question like this right here, because the second equation is sort of strange. There's no x anywhere. Back in our old notes, I believe it was section 5.6, we talked that this was going to represent a horizontal line at the y-intercept of negative 4. So you would go ahead and you draw that horizontal line this way. Again, we can see that one of our equations isn't ready to graph, in particular this top one. So what I need to do is move my x's over to the other side, leaving me with 2y equals negative 3x plus 4, and again I must divide by 2, giving me that my final graphable equation would be negative 3 over 2x plus 2. So I start with the y-intercept of 2. The slope is telling me go down 3, go right 2, go down 3, go right 2, and there is the intersection. The intersection is at 4, negative 4. And just remember, as a final word, it's x, y. So right there I counted, I went to the right 4, and I went down 4. 4, negative 4. So that's our short video, let's see, on graphing the solution to a system of equations. Let me know if there's anything else that you want me to go over, and let me know if this video was helpful. Thank you.